Alright, hey guys, Mr. Astro here. So today I thought about talking about a comet called C 2024 G3 Atlas, which is a sun-grazing long-period comet that could be visible in the next few weeks. So today is the last day of 2024, so Happy New Year's to everyone who is celebrating this. It's quite funny I'm making this video on that date actually. I don't normally do videos on last days of any year, but anyways, comet. So we're going to be talking about that today. I'm going to be doing something slightly different. Oh no, this is very different. I'm going to go through things like night sky emulators and information about the comet in this sort of presentation sort of way. I've never done it before, so but this is going to be really authentic, so let me know what you guys think about this kind of style of videos. I might do more of it because it is a bit more realistic, I guess, or authentic, I don't know. But anyways, let's talk about the comet. So I'm going to show you what it is basically. So here it is. I've got several sources here. This is on Google. So let's look through the Wikipedia page firstly. Now let's turn on dark mode because this is not what we want. There we go. So yeah, this is the comet's name, Atlas. So Atlas stands for Asteroid Terrestrial Impact Last Alert System. So this comet was discovered or surveyed on 5th of April this year, or 2024 should I say, with a 0.5 meter refractor telescope in this place here, Rio Hurtado in Chile. Oh my god. See, this is what I mean by authentic. At the time, it was a magnitude 19 object. I just went straight into the history of it. I didn't even tell you what this is. No, shut up! This is what I mean. Oh my god, no, I said no. So yeah, this is a long period sun-grazing comet. So sun-grazing means a comet that is extremely close to the sun. So as you can see in this animation here of this comet, that is a very bad resolution, but you can see it is very, very close to the sun. And when it comes to sun-grazing comets, they can typically disintegrate. So we'll have to see what this comet does here, this one here. So it reached perihelion on the 13th of January 2025. So perihelion basically means, perihelion means the orbit of a celestial body where it passes closest to the sun, and it's the opposite of aphelion, which is furthest away. And at the same time, well, around the same time, Earth will reach perihelion in early January. So comet passing the sun in a perihelion on January, as well as the Earth. Great. At a distance of 0.09 astronomical units from the sun. So to put it into perspective, 1 astronomical unit is the distance from the Earth to the sun. So 0.09 is very, very close. And it could be the brightest comet of 2025 so far, or ever. I mean, we'll have to see what next few months will come up with. And it could possibly exceed magnitude of -3.95. So to put it into perspective, if Venus, so let's load up Stellarium. Venus here is on a magnitude of -4.42, so which is very bright, and you can see it here. So the comet will be near that brightness. But there is a bit of a catch, and I'll explain that later. The comet is visible in the southern hemisphere right now, before and after perihelion, and I'll show you why. And it can only be observed in the daytime sky around perihelion in the northern hemisphere as a catch as well. So yeah, I just talked about the history. No, thank you. What the heck is this? I'm not paying. Yeah, magnitude 19. That was when it was discovered from Earth. 4.38 astronomical units. 12 observations, views Comet on 4.5 arc seconds across and a straight tail. So yeah, At the time of discovery, it was assumed that it was a new comet from the Oort cloud, which is where all the comets, or at least lots of comets, are held. And that's the furthest away from the solar system. As you see, got the planets here, then the Kuiper belt somewhere here, interstellar space, and the Oort cloud, which is massive. And with its very weak absolute magnitude, which I don't know what this means, there was a very little to no chance that it will survive perihelion. So that's the catch. Well, at least it could disintegrate. Very little to no chance that it will survive perihelion. So things can change basically. But as the orbit was refound, it was found likely to be a dynamically old comet, which has made close approaches to the sun before. Let's see what this one does. By 30th of October, near Halloween, the comet had an apparent magnitude of 11.9, which is still faint, but they saw it, COBS. With very large telescopes, by mid-December 2024, it had brightest to 8th magnitude and was located in Scorpius, which is this constellation. So this constellation here, Scorpius, that's where the comet is. Well, it's a bit above now, as of today. Here, let me pull up measurements. So the comet was here, Scorpius is about there, so that's like 9 degrees further, which is pretty lengthy. Visible at dawn in the southern and equatorial regions. By the end of the month, so around this time, its magnitude is reported to be between 5 and 5.5. And if we look on here, the comet is at magnitude 6.8. Having a coma around 2 arc minutes, across the tail up to 18 arc minutes long. I don't know how long that is, but okay. In case of this comet was, in case of this comet was very difficult to predict peak brightness, right, spread more than 10 magnitude, this person or whatever predicts -4, so that's around the brightness of Venus, so, around there. Accounting for forward scattering, which is this. However, it'll just be 5 degrees from the sun at peak magnitude. After perihelion, the comets head southwards. Mid-northern altitudes will be low, between 2 degrees. Yeah, civil twilight. So that is what Wikipedia said. It's a bit of a summary here. Yep, there you go. Okay, let's look at the orbit. So I don't know how to turn this into dark mode, so I apologize. But this is a comet from Small Body Database Lookup. This is from NASA JPL, so yep, this laboratory. So this is the orbit of the comet here, and this is a 3D simulation. So we've got all the planets here. If we zoom in, we've got the inner planets, and we've got the comet here. As of midnight UTC of today, the comet is around there. So if we look from ahead, it is between Mercury and Venus's orbit. And if we look at the plane of the solar system, it's just below that. And you can see it is very close to the sun. Was it 0.09 astronomical units? So if we forward the time now, oh, there was this. I didn't even realize. Okay. So if we forward in time, days, so you can see the comet gets closer. The 13th, which is that date. Yeah, you can see it is pretty damn close. Yeah, if we look from above, you can see that is just crazy. That is super close. And it'll be bright. So if we go back, so this is where the comet was. So let's go back to the April time where it was discovered. Well, I selected them 10 days. Alright, my fan on my laptop is so loud. So it was around then that the comet was discovered, and it was just so if we look from above, the comet was just around the orbit of Jupiter, and then looking at the plane, it is still pretty damn far away. This is the, like, was it the inclination? It is very steep. From what I heard, is about 116 degrees. So this line here is 90 degrees. That's 116. So that is very steep. Alright, so let me just explain the angles a lot clearer. So this line here is 90 degrees. Oh, I forgot to draw. Blue. So this is, oh God, that's thin. Where's the anti? There we go. 90 degrees here. This line, oh my God. Wait, hang on. 90 degrees. No, that's not even straight. That's killing me. We'll go with that. So that's 90 degrees, sort of. This comet is 116 degrees. Yeah, 116 degrees. That is very steep. So this line here is where the plane of the solar system's planets are mostly are, the orbits. Yellow line is the comet, how steep that is, and the blue lines are the 90 degree one. So that is very steep, as you can see. So the planet, yeah, that's the planet's orbit. You can see that it's not perfectly in line, because some orbits are a bit, you know, tilted and stuff. This comet's orbit just, yeah. I think that's typically the thing with comets, though, and any other minor objects, I'd assume. Yeah, it will, you know, pass by. Oh Jesus, we're going too far. We're in 2028. What else do we have? We've got a lot of statistics. Don't worry about that unless you're like really into that kind of stuff. Yeah, the source is JPL. So yeah, hyperbolic comet. And that is from there. So alright, let me show you some pictures of the comet. So these are totally AI generated. That's not it. Alright, here you go. Here's a bit of a preview. I don't know where exactly these locations are. Oh, we know they're just both hemispheres. But that's in the morning on the 13th, wherever that is in the northern hemisphere. Southern hemisphere, you got a bit of a better chance in the evening. So, right. Have we got the official pictures? Is this it? Well, I don't know. Oh, hang on. Oh, that's a simulation. But there you go. That's how the tail will look like. You see, it is very big, you know. So, that's good. Right, this one's interesting. Whoa. Can I zoom in more? Zoom mode. Wait, what? Toggle magnification mode and then... How do you... Whoa. Okay, so this was on the 27th of May, 2024. That's the comet right here. That's like something. Nice. Okay, so that's the information about the comet and what it kind of looks like. Now I'm going to show you what it will look like in this night sky, which is more fun. So this is Stellarium, and this is right now in this place in the UK. So we got, you know, night sky here, got planets out and wind constellations, but that's not what we're focusing on. We're focusing on the comet. So let's go back to daytime ish. Yep. Whoops. Okay, so I've got the comet already selected, so let's center that just below the horizon. So this is, let's look at the UK and then other locations. So if you're in the UK, so you won't be able to see it for the next few days, but as we go towards like the 13th, you can see it becomes visible-ish. But you can see it is very, very close to the sun. Now, I heard from Wikipedia you could see it in the daytime apparently, but we'll have to wait and see. Comets are unpredictable, let's just say that. This one's very, very low. So, but it's a magnitude -1.3. Oh geez, we have a hard time. It'll be a hard time for us to see this one here, especially with the twilight combined. Reduced to no. Oh, right. That's 30th. The 14th. A little bit better-ish. Not, I don't know. It is very faint. I mean, if you're trying to see this, maybe binoculars and a telescope could be. Definitely a telescope, but and a really clear horizon to the southwest. And if we look at the compass, so looking around here is what's this? 235-ish somewhere. I don't know. 15th. I got a bit of a good chance. Or not. I mean, it is very difficult to spot this, and if you are looking at this today, you need to be very careful. It is so close to the sun. 16th, and it becomes lower. By 20th, you won't be able to really see that. So in the UK, basically, it's very hard to spot it. UK. I will try to find this, but I'll have to wait and just see what happens, you know. Got Venus and Saturn. They're going to conjunction on 18th, which is nice. Right, so that's the UK sorted. Let's go to Tunisia. Tunis. Right, so this is going to be Tunisia. Let's go back to the start of January. Atlas. There we go. So it's like the UK. I mean, wait, what's the 13th like? Oh, yeah, you're not gonna have a good chance really. The 15th, 16th, and 17th, you might have a good chance. 18th, 19th, 20th. To like the 25th, something. This 17th, 18th. Hang on. Right, let's go with the 16th. So at least look if you it's gonna be slightly less darker with the twilight. But definitely get a telescope or binoculars for this, because yeah. Right, let's go to USA, but it's going to be similar as well. It's not going to be much exciting. Let's just go here. Yeah, we're looking at a very similar scenario. So, yeah, telescopes and binoculars. I think telescopes are definitely going to be something like to keep an eye out. Binoculars, I mean, you might get a chance. We'll have to just find out. Especially got a good pair of binoculars dedicated for this kind of stuff. I've got a 15x70, so I might be able to see that with it, but we'll have to just see. Right, so that's like northern hemisphere, so that's all around this latitude. How about if we go towards the equator? So let's say if you were in what's this, Indonesia, Malaysia, I think. Right, so this is towards the equator. So you guys in like the equator, you get a better chance actually. So if we go to the 13th, oh hang on. Wait, 13th. Oh, so apparently this is what I mean by authentic. This is like real time. But if we go to the site, you know, 15th, 16th, 17th, 18th, 19th, and I think it's gonna be onwards, the comet will get higher and higher, but fainter. So binoculars and telescopes. But I think if you're trying to see this with naked eye, I mean, I don't know. It is very low. I mean, look like you might be able to see the tail. So yeah, you'll get a better chance at least, unlike us in the northern hemisphere. So this is after perihelion. If we go to before perihelion, well, I think you might be able to see it in the morning skies actually, because I never really mentioned that. Yeah, look, morning skies. And there's Mercury nearby, so yeah, morning skies as well at the start of January. For us in the northern hemisphere, we won't get to see the comet in the morning before perihelion, because that's below. Well, I mean, depending where you're on the latitude actually. If you were, I don't know, let's say Dubai, somewhere there, morning skies, you get a bit of a chance at least. It's near Mercury, so if you know where Mercury is, it's just below. No, that's exoplanets, which there is a lot in this area discovered. About 5 degrees, which is nice. I don't know what I'm doing here. Right, now if we go to Australia for example, so here in the desert, morning skies. Oh yeah, I forgot, this is where like South Celestial Pole is there. So morning skies is like in the equator-ish area. You'll see in the morning perhaps. I'm looking at around these days, especially like this is now. Well no, this is gonna be now for you guys. In fact, what time is it for you there? Whoops. Ah. So in Australia it's just past sunrise. The comet would have been there. And onwards they'll get closer to Mercury, but to the sun especially. And then southern hemisphere, not southern hemisphere, after twilight in the evening, perihelion, you won't be able to see it, but past that you would. So definitely keep an eye out for that. I hope I'm making sense here. I'm just explaining what I can see, you know. I don't know if I'm doing a good job on this or not. I mean, if you guys like this type of videos, I'll do more of them. I'm actually finding this much easier than I'm expected. Right, and if you guys were in Antarctica, well, it's interesting because the sun does set, but it doesn't go low. But it's not really. Okay, well, hang on, this is good. That's in February though. So there's the comet here. So, and then if you're in Greenland, or Iceland actually, Iceland, it's not the best. Hang on, 13th. Yeah, it's not, no. It's too low. Right, so I feel like I've explained everything about this comet. So guys, that is C 2024 G3 Atlas, explained in the best way I could in authentic real time. So yeah, I hope this all made sense and I hope you guys enjoyed it. I try my best to keep it easy to understand, but I feel like I just kind of rambled on about everything else. So yeah, that's the comet, guys. We'll have one final look at the orbit before I close this video off. What is this? How do I get? No, I'm gonna get no. How the heck do I get rid of this calendar? I want to go into full screen. Oh dear, let me just reset this. Alright, there we go. So that's the ending page, which is the orbit of the comet, and this is where it is now, down there. Alright, so that's the comet, guys. I hope you enjoyed this video. It might be complicated, oh well. I'll leave some sources in the description for you guys to understand and read through. And obviously check out night sky apps like Stellarium, Sky Guide, Sky Safari, because They will guide you this comet better than I could. So, thanks for watching, and I'll see you in 2025. Happy New Year.
Imagine a celestial object brighter than Venus, visible even in daylight. That's exactly what astronomers are buzzing about with Comet C 2024 G3, Atlas, set to grace our skies in early 2025.
Whoa, hold on a second. A comet brighter than Venus? That's not something you hear about every day. What's the story behind this cosmic visitor?
Well, it all started on a quiet night in April 2024. Astronomer T. Linder was using the Asteroid Terrestrial Impact Last Alert System, or ATLAS for short, when they spotted a faint fuzzy blob in the night sky. Little did they know, this discovery would soon captivate the astronomical community.
So it was just a tiny smudge at first. How did we go from that to predictions of a dazzling celestial show?
That's the fascinating part. As astronomers tracked this comet, they realized its orbit was taking it on a journey right into the heart of our solar system. On January 13th, 2025, it's going to make its closest approach to the Sun, swinging by at a mere 0.09 astronomical units. That's about 13.5 million kilometers from the Sun's surface.
Wow, talk about a close shave. I'm guessing that's why it's expected to be so bright?
Exactly. As the comet heats up during this close encounter, it's expected to put on quite a light show. Some optimistic estimates suggest it could reach a magnitude of minus 3.5 or even brighter. To put that in perspective, Venus, the brightest planet in our night sky, shines at about minus 4.6 at its brightest.
That's incredible. But, I'm sensing there's a catch here. What's the downside to having such a bright comet so close to the Sun?
Well, you're right to be suspicious. The catch is that observing the comet will be quite challenging due to its proximity to the Sun. It's like trying to spot a firefly next to a spotlight. For folks in the northern hemisphere, the comet might only be visible in the daytime sky around its closest approach to the Sun.
Oh, I see. So we've got the classic look but don't look scenario on our hands. How are stargazers supposed to safely observe something that's practically hugging the Sun?
That's a great question, and it's crucial for our listeners to understand the safety precautions. Never ever look directly at the Sun with or without optical aids. It can cause severe and permanent eye damage. If you're planning to observe during the day, it's best to attend a public viewing event at a local observatory or astronomy club where experts can guide you safely.
Solid advice. We want our listeners to see the comet, not end up seeing stars for all the wrong reasons. So what about the Southern Hemisphere? Do they have better luck?
Indeed they do. Our friends in the Southern Hemisphere might have better chances, potentially catching glimpses before and after the comet's solar rendezvous. As of the end of 2024, the comet was already putting on a pretty good show. It had brightened to a magnitude of 4.9, making it visible with a good pair of binoculars or a small telescope.
That's exciting. Now, I'm curious about the comet's orbit. I've heard it's got some unusual characteristics. Can you tell us more about that?
Absolutely. Comet C 2024 G3 has some fascinating orbital characteristics that make it stand out. Its orbit has an eccentricity of 1.0000141, which indicates a hyperbolic trajectory. In simple terms, this means the comet is on a path that could potentially take it out of our solar system after its close encounter with the Sun.
So, we're dealing with an interstellar tourist here. That's pretty mind-blowing.
Well, not quite. While the orbit is technically hyperbolic, it's only very slightly so. The comet's orbital period is estimated to be about 135,000 years inbound and 450,500 years outbound. These incredibly long periods classify it as a long-period comet rather than a true interstellar object.
Oh, I see. So it's more like a very infrequent visitor than a one-time tourist. Still, those are some mind-boggling numbers. It's amazing to think that the last time this comet visited the inner solar system, our ancestors were still in the Stone Age.
Exactly. And here's another interesting tidbit about its orbit. The comet's inclination is approximately 116.852 degrees. This means it has a very steep orbit relative to the ecliptic plane, which is the plane in which most planets orbit the Sun.
I'm guessing that steep inclination contributes to the observational challenges we discussed earlier?
You've got it. The steep inclination, combined with its close approach to the sun, makes observing this comet a real challenge. But it also makes it a unique and exciting target for astronomers and amateur stargazers alike.
Speaking of challenges, what are the chances this comet will actually survive its close encounter with the sun? I mean, that's a pretty toasty neighborhood it's visiting.
That's the million-dollar question. Comets that get this close to the sun are called sun grazers, and they don't always make it out in one piece. The intense solar radiation and gravitational forces can cause them to break apart or even completely disintegrate. It's like nature's own reality TV show, their Survivor Solar System Edition.
Laughing. Now that's a show I'd definitely tune in for. But seriously, how does this uncertainty affect our chances of seeing the comet?
Well, that's why astronomers are cautioning everyone to temper their expectations. While some predictions suggest the comet could reach an incredible magnitude of -4.5, we won't know for sure until it happens. The behavior of comets can change rapidly, and new information could affect viewing strategies.
So what you're saying is, we should hope for the best, but prepare for the possibility that our cosmic visitor might ghost us?
Precisely. And that's why it's so important for our listeners to stay tuned to astronomical forecasts as we get closer to January 2025. But even if the comet doesn't quite live up to the hype, the journey of discovery and the excitement of anticipation are what make astronomy so thrilling.
I couldn't agree more. Now, as we wrap up, what would you say are the key takeaways for our listeners about Comet C 2024 G3?
Great question. I'd say the main points to remember are: first, we're potentially in for a spectacular celestial show in early 2025, with a comet that could outshine Venus. Second, observing it will be challenging due to its proximity to the sun, so safety is paramount. And finally, the unpredictable nature of comets means we should stay tuned for updates and be prepared for any outcome.
Excellent summary. And I'd add that this event is a great reminder of the dynamic nature of our solar system. It's not just a static place, but a cosmic neighborhood full of surprises and wonders.
Absolutely. And on that inspiring note, I think it's time we wrap up this stellar episode of Gen FM. To all our wonderful listeners out there, thank you for joining us on this cosmic journey. Remember to keep your eyes on the skies, your feet on the ground, and your sense of wonder always at the ready.
And don't forget to mark your calendars for January 2025. It might just be the perfect excuse for a summer vacation to the Southern Hemisphere. Who knows? You might witness a once-in-a-lifetime celestial spectacle.
Always thinking ahead, aren't you? Well, until next time, this is Gen FM, signing off. Keep looking up, everyone, and may the cosmic forces be with you.